So here's an optimization problem where we're supposed to maximize a volume given a certain amount of money. It's a word problem, and it doesn't really matter what this word problem is about. We're going to have to label the picture. We know we have a width, and we know the length is 3 more feet than the width, so our length is W plus 3. They didn't tell us anything about the height, so I'm just going to call it H. And then, since I want to maximize the volume, I know that's my focus. The volume is the width times the length times the height, and I've got the start of my problem. But the issue here is that we have 2 variables. We have W and we have H, and we want 1 variable. And so we've got to go find a constraint. That's where the $300 is going to come in. So here's our situation again. We want to pay for this box. Now, this is the cost of the bottom. We've got the area of the bottom, W plus 3 times W. That's the area of the bottom, and the bottom costs $5 per square foot. Then we've got the sides, W times H, and that costs $3 per square foot, and there's 2 sides of the exact same size, so we're going to double that cost. Then we have the area of the front and back. Each is W plus 3 times H. That costs $3 a square foot, and again we're multiplying it by 2 because there's 2 sides of the exact same size. That's how much money it costs to build this, so it's going to equal $300. And when you simplify that, you get this lovely equation. Now we need to solve for one of the variables. H is going to be the easiest to solve for because you've got a quadratic with W squared there. So I would go ahead and move this term and this term over, right? You subtract them from both sides. And I'd factor the H out of what's left to end up with this. That allows us to solve for H when we divide by 12W plus 18 on both sides. Okay, that was a lot of work, but now we know what H is in terms of W, and we can go back to our focus. The volume, there's what H is. We are going to take this and plug it in right there. There's our equation. Now, we have to graph this to solve for the maximum, because again we're looking for the maximum volume. Therefore we need to type it into our calculator. This is what it's going to look like when you type it in. Notice that instead of W, of course, we use X, so when we graph it, the X is going to be our width and the volume is going to be our Y. So we graph it, it looks something like this. We find the maximum, and here's the maximum X. This is the Y that is maximum. This actually is the volume because Y is the volume. But we're not asked about the volume. We're asked what are the dimensions of the box. So we actually want that X. To get the maximum volume, the width is 3.35 feet approximately. And then the length, remember the length is 3 more feet than the width. So add 3 to it. The length is 6.35 feet. And then we have this lovely equation here for the height. We just need to plug our W in, or in this case our X in, to get the height, and we get the height approximately 3.33 feet. And we're done with the problem. We answered the question.